So good evening everyone. So today we are going to continue with the organic chemistry reactions which we discussed in the Tuesday's class. So in the previous class we have discussed about substitution, that are only two, that is NSR and ESR. Before I move on to this topic, I just want to give the answers for the previous session homework. So the question which I asked you as a homework was, alcohol shows which reaction. So the formula for alcohol is, let us just check what is the formula for alcohol first. Right. So alcohol is nothing but ROH. Whenever the bond cleaves, OH will be negative and carbon will be positive. So negative charge will come and replace this OH. That's why we say nucleophile is coming in, causing this substitution known as NSR. That means the answer is NSR. I think I already told you the first state of the reaction, that is alcohol and RX, that is halogen containing compound. They both shows NSR reaction. So the answer is A. So who have written A answer is very good. Next, the question is alkyl halide shows which shows Walden inversion. Hope you remember that Walden inversion is nothing but SN2. SN2 the sequence will be methyl, then primary, then secondary, then tertiary. Then where is methyl here? The answer is G here. Next, moving on to which one is not a ESR reaction. ESR is electrophilic substitution. I think I told you the simple trick, memorize here too. Wherever you find benzene ring compound, like anywhere, if you find benzene ring, you should understand that they undergo ESR. So let us know, which one is not a type of ESR they are telling. Yes. So the benzene ring always undergo ESR. Containing compound, benzene ring containing compound always undergo ESR. So the question is which one is another type of ESR. So we have discussed that there are 4 types of ESR. The one is halogenation, second is nitration, sulfonation, Friedel-Crafts reaction. So halogenation, nitration, sulfonation, Friedel-Crafts reaction. Friedel-Crafts again 2 types. The one is Friedel-Crafts alkylation and Friedel-Crafts acylation reaction. So nitration is an example, yes. Sulfonation is an example. Alkylation is not an example, but carboxylation is not an example. That means the answer is going to be C for the homework for the third question. Hope you got the answers. You got this all 3 answers. So moving on to the today's topic. So So to get the latest updates, please download our Spark Academy app from the Google Play, where we run the daily classroom classes and all, where we run the daily classes, and we'll get the materials which we are providing by the experienced faculties. So the schedule is right from Monday to Friday, and organic chemistry, that is by me, Hajera Maa'm, on Tuesday and Thursday, that is 5 to 6 p.m. And if you have other doubts of organic chemistry other than this part, you can also ask in the chat box or in the Telegram group, or in the not Telegram group, sorry, in the Spark Academy app. Sorry. So we have the various courses running right now. We even are going to start a short-term course, that is from 20th May. To get the 10% discount, you can download the coupon, you can download the app, and you can join our courses to get the 10% discount. HAJ10 should be used. Next is coming to session plan. So today we are going to talk about the classification. I think we have already done. Today we are going to talk about the substitution, which is continuation of the previous topic. Adhesion, elimination, rearrangement. Certain practice questions and PYQs are not asked from this part. So we'll omit the PYQs and you can carry the homework as usual. So let us give a brief introduction to the types of organic chemistry reactions. So I think I already told you that there are 4 types of reactions. The one is substitution, second is addition, third is elimination, and fourth rearrangement. So substitution is again three types: NSR, ESR, FRSR. In the yesterday's topic, or in the day before yesterday, that is on Tuesday's topic, we have discussed this too. We'll start with FRSR. And addition is again three types: NAR, EAR, and FRSR. Elimination is two types: alpha elimination, beta elimination. Rearrangement is no further types. Simply, it's simple reaction. It comes really in a chemistry. So I think we have discussed that already. Moving on to the next one called as free radical substitution reaction. The name says free radical means unpaired electron. So wherever you have unpaired electron, they are called as free radical. Free radical is causing substitution and hence known as free radical substitution. The example here is halogenation of alkane. So whenever alkane undergo reaction with halogen, that reaction is known as halogenation of alkane, and the mechanism is FRSR. So we understand the mechanism. What is alkane? Carbon-carbon single bond, right? So what I'll do, I'll just draw any of the alkane. I'll take like CH4. You can take any carbon, 2, 3, 4. I'm just taking methane, which is 1 carbon. This is an example of alkane. Halogenation means you should treat with halogen. Any of the halogen you should use, like chlorine I'm using. And please remember that alkanes won't easily react. Hence, we should use high temperature and pressure. High temperature and pressure. That's why above the arrow you should put higher temperature, pressure, or you can even use the sunlight, which is source of high temperature or heat. You know that you just look here, the ethane is or methane is like this. This is methane, obviously. You can see that whether it is ethane, methane, or any alkane, all bonds are satisfied with hydrogens or carbon, right? And there are no extra bonds, so that chlorine cannot come and get it added here. Chlorine cannot come and get it added here. It means chlorine, whenever it comes, it should replace one of the hydrogen, isn't it? Let us understand how the bond of chlorine breaks. See, the two chlorines are similar. Two atoms are similar, and there is no electron negativity difference between these two atoms. Hence, the bond whenever bond cleavage occurs, the bond cleave by homolytically, and they will take their own electron. That means you will get free radicals of chlorine when the bond cleaves. That means chlorine is coming in the form of free radical. So whenever chlorine is coming in the form of free radical, it will replace one of the hydrogen and leads to formation of CH3Cl and one more HCl, one more H which went react with one more chlorine, leading to formation of HCl. You can see that here chlorine is coming in the form of free radical. Chlorine is coming in the form of free radical and attacking the alkane and replacing the hydrogen. Replacement is nothing but substitution. What is coming first? Free radical is coming, hence the name of the mechanism is free radical substitution reaction. Hope you understood you got the mechanism. Why it is known as free radical? Because chlorine, whenever the bond cleaves, homolytically cleaves, and you will get free radicals of chlorine. Chlorine free radical is coming and attacking hydrogen and replacing one of the hydrogen, hence called as substitution, free radical substitution. So hope it is clear for you the mechanism. Then moving on to the next is, so with this we finish substitution. Moving on to the next step called as adhesion reaction. I think it's very easy for us to understand the meaning of adhesion. Here nothing is broken, nothing is eliminated. Only the bond is getting broken, that is usually pi bond. Please remember, wherever you find pi bond containing compound undergo adhesion. reaction. So wherever you find extra bond, wherever you find pi bond, extra bond means nothing but pi bond. Wherever you find pi bond, please tell that reaction undergo addition. But depends okay, what type of addition we have. We have three types of additions. The one is NAR, nucleophilic addition reaction. Here the example you need to memorize here is all carbonyl compounds. Carbonyl compounds. So we'll see what do you mean by carbonyl compounds. Oh, we already discussed that carbonyl compound. Yes, very good evening, Bhavna. Very good evening. Have you uploaded the answers, homework answers, Bhavna? I couldn't receive. I did not receive, na. Right. So what is mean by carbonyl compounds? Wherever you find C double bond, they are called as carbonyl compounds. The one side can be R, or one side can be H. This is known as aldehyde. Or if you want, you can take both sides R. That is known as ketone. Okay. You can take any of this one. I'll take aldehyde. You can even use this aldehyde. So anything you should add, like water or anything, whatever you want to add. Now just look here. I'm adding HCl, hydrogen cyanide. So you know how hydrogen cyanide will break? It will in the form of H plus and Cn minus. Now the cleavage of the HCN is we got, but whenever the pi bond breaks, what do you think the cleavage is? The cleavage is again heterolytically because carbon oxygen electronegativity is much more, hence oxygen will get negative charge and carbon will get positive charge. You can see that H plus also will come, H plus will go to oxygen and cyanide will go to carbon. It's very clear because you know, right, positive and negative attracts, hence obviously, hence negative and positive will get reacted. But the question here is, scientists or the chemist found that in case of carbonyl compound, negative charge goes first. What is going first? Cyanide is going first. Cyanide in the form of cyanide is nothing but negative charge. Negative is known as nucleophile. What it is doing, it is causing addition, hence known as nucleophilic addition reaction. So what I'll do, I'll first add cyanide. Okay, then H was as it is. It was O minus. Now O minus. Next H came later. It will become OH like this. So you can see it's simply that wherever you find carbonyl compounds, tell that the mechanism is NAR, nucleophilic addition reaction, because the pi bond which is there in carbonyl compound getting broken, and you know nucleophile will get added first. Then positive charge also will go, but negative charge will go first. Negative charge is known as nucleophile. Hence, the mechanism is NAR. Hope it is clear for you. It's very important mechanism actually. Moving on to the next addition class. No, Bhavna. You want carbonyl compound examples? The carbonyl compound examples here are, I'll give, I think, do you remember we have a list of 15 functional groups? You will find there almost 7 are there. This is aldehyde, C double bond O, R on both sides, ketone, R C double bond O, OH is carboxylic acid. If H is replaced by R, it's known as ester. And if in case of C, OR ester, OH is carboxylic acid. And if you have RCONH2, it's known as amide. RCO, actually you cannot see if I write there, okay. Please go to the list of functional group, you will find also there. This is amide and this is RCOOX, X is acyl halide, RCOOCO, R is known as acid anhydride. We have almost 6 or 7 list. Next, moving on to the next type of addition called as electrophilic addition reaction. The name says electrophile is coming and causing addition. That's why known as mechanism is electrophilic addition reaction. The very important this reaction actually. The example is addition of addition of alkene in presence of acidic medium. Acidic medium symbol you can write as H plus. Please, very important. Acidic medium is H plus. So we'll write an example. So what is the example here for EAR? Addition of alkene in the presence of acidic medium. That means anything which is getting added to alkene in the acidic medium, always electrophile will go first. That is according to the scientists, they said whenever alkene is getting it added, electrophile will go first. So, and you know, right, both come as equal anywhere it goes. In that case it will become CH3, then chlorine goes later, it will become CH2Cl, isn't it? First hydrogen went, then it is getting added here, chlorine came later, first what came? H plus came. H plus is nothing, plus is nothing but electrophile. Hence the name of the mechanism is electrophilic addition reaction. It's very, very, very important. Okay, right. So moving on to the third one called as free radical adhesion reaction. So let's write an example. What is the example for that? Is addition of alkene in presence of, see, this is almost similar, addition of alkene in presence of. The solvent was in the above one case was acidic medium. Here the solvent is peroxide. If you find any peroxide above the arrow for alkene, the mechanism is going to be free radical addition reaction. Let's see an example here. So any peroxide you can use, H2O2 benzoyl peroxide, any peroxide. You know, whenever the peroxide is there, the bond of this HBr, you see, this was HCl, the bond is getting cleaved unequally. H plus and Cl minus you are getting, hence you are getting free radical, hence you are getting electrophile and nucleophile. Electrophile was attacking first and getting added here in that above case. Whereas in the case of HBr, whenever peroxide is there, the bond is cleaving homolytically. You know that if the bond is getting cleaving homolytically, you will get free radicals. Definitely free radical will go. Free radical, which free radical is going? Bromine is going here. In that case, bromine is going first. It will become CH2, anywhere it can go, CH3, CH2Br. So look here that the thing here is solvent. If you change the solvent, mechanism is getting changed because the thing they said is, scientists or the chemist said is, whenever peroxide is used as a solvent, the cleavage is different, that is homolytically, you will get free radical and the mechanism definitely is going to be free radical addition reaction. Hope you got the difference. That's all the difference in between this ER and FAR. The question is, H plus can be added to another CH2 also, ma'am? So yes, in these case, Bhavana, you can find that both carbons are similar. You can add here or here, no problem. So I'll tell you the one thing here, you are asking here, but I thought that I would explain in alkene. So you just look here, what I'll do, I'll clear with the thing. And let me tell you one thing, Peroxide has effect only on HBr. No other, it cannot act on HCl. It cannot act on HF, HI. Only peroxide acts on HB. That means everywhere alkene undergoes EAR. Only one time only undergo FAR. That's all. Let's go back to the Bhavana's doubt. It's a nice question, but I thought to explain in alkenes. So what I'll do, I'm using acidic medium. H plus and Cl minus will get. H plus will go to the carbon. Both are same, right? You can add here, no problem. So it will become, because both the carbons are having equal number of hydrogens. So anywhere it can go because the both are same. If you add there, the product would be same only. CH3, CH2, Cl, isn't it? Now just consider if H plus goes here, it will become the same only. CH2, Cl, CH3. Both are compounds same. Now what I'll do, I'll change the alkene which is having unequal number of hydrogen. That important role comes here of H plus. Again, acidic medium. How HCl will break? HCl will break in the form of H plus and Cl minus. Now what goes first? You know that H plus will go, because already discussed that in acidic medium the mechanism is electrophilic, means electrophile will go first. H plus is going. Now H plus has two chances. It can go to this carbon which is having two hydrogens. It can go to this carbon which is having one hydrogen. So what do you think, Bhavanadamo? H plus will go to this carbon and this carbon. Here in this case both hydrogens are similar. It can go anywhere. And the product would be equal. Product name will be equal, same only. But here in this case, if it goes here, name will be different. If it will go here, name will be different. So the chemist said that H plus will go to the carbon containing more number of hydrogens. So you see here, to this carbon it has two hydrogens, and to this carbon it has one hydrogen. So according to the scientist, H plus electrophile will go to the carbon containing more number of hydrogens. So H plus will go here, chlorine will go here. So leading to formation of CH3, CH, Cl, CH3. This rule, we are not telling that, they are telling. Who is telling? The Markovnikov scientist is telling. Who is this scientist? He is, Wesley. No need to know, sorry, actually, who is this. Simply remember that the scientist's name was Markovnikov. He said that electrophile will go to the carbon containing more number of hydrogen. This rule is known as Markovnikov's rule. So what is Markovnikov's rule? The positive part of reagent will go to the carbon containing more number of hydrogen in unsymmetrical alkene. This is known as unsymmetrical alkene. Why it is unsymmetrical? Because both carbons on either side are unequal. Here both were equal and we had no problem to attach here and there, because if you write there and here, the product would be same only. But if you write here, the product would be different. But in that case, rule is followed. That rule is Markovnikov rule. H plus will go to the carbon containing more number of hydrogen according to this, right? Oh, Bhavana, it does not go to the low carbon, high carbon. No, it does not. Markovnikov may, it will not go to the carbon containing less number of hydrogen. It will go to the carbon containing more number of hydrogen. That means here it is, right? So please remember. So you got now? Please tell me, you cleared the, you got it? You got it? So I think so we have finished addition reaction. Moving on to the next one known as elimination. The name says elimination, atoms are getting removed. But please remember that whenever you are doing elimination, two atoms you should remove. One atom you cannot break, because if one atom grows, it is difficult for the atom. The atom will develop positive charge, or negative charge or free radical, which is unstable, which is not possible. So for elimination, you should remove two atoms. Next question is, how many types of elimination we have? We have only two types of elimination: alpha elimination, also called as 1,1 elimination. So we'll see what do you mean by this. So look here, in that case, like zinc is coming, consider any other reagent is coming, right? Any other catalyst is coming. So they are getting removed. That is, halogens are getting removed. Two halogens going here. You can see that two atoms are getting removed. hence an elimination. Now, atoms are getting removed, simply elimination. And look here, why it is called as alpha. What do you mean by alpha? Please remember this word, which is, alpha is a very important word in a chemistry. Alpha refers to carbon next to the functional group. You can see that chlorine is a functional group here, chlorine is a functional group. Next, the carbon next to the functional group is known as alpha carbon. That means two atoms are removed from the same alpha carbon, is known as alpha carbon, and two atoms are removed from the same, that is first and first carbon, that is known as alpha elimination. So you can write as alpha elimination or 1,1 elimination, both are the same meaning. Right. So simply, and this mechanism does not occurs in a chemistry. Only beta elimination occurs in a chemistry. So we'll understand what do you mean by beta elimination. Beta is elimination is important. 1,2 elimination. Consider two halogens on the adjacent carbon. Like any atom is getting like zinc is coming in. Whenever zinc comes, 2 chlorine it takes away. This also will go. This also will go. Now leading to formation of double bond with this. So it will become CH2 double bond CH2 plus ZnCl2 will form. Now look here that atoms are getting removed, elimination. The question is why it is called as beta. Consider this is alpha carbon, this is beta carbon. Atoms are removed from the beta carbon, hence known as beta elimination. This is first carbon, this is second carbon, 1,2 elimination, that's all. Right. Oh, you are replying but I'm getting late. Oh, okay, yeah, I heard that the things are late to appear to you and late to appear to me as well. Okay, so elimination is also finished. Beta elimination comes in studima, alpha does not comes. That's all. Please remember the meaning of alpha and beta. That's all the important thing here is, and beta also is important elimination. Now, the last reaction is rearrangement. The name says getting the atoms are getting shifted, rearranged. I think the best example to explain here is ketone tautomerism. So this is like ketone form, right? Immediately get changes. This is, what happened? This bond shifts here, hydrogen shifts here to the oxygen. It leads to formation of CH3. Oh, I'll better write. So ketone tautomerism is the best example to explain rearrangement. Hydrogen will go to this oxygen. Bond will go here. OH at weekend. Pi bond comes here, that's where carbon-carbon double bond will get changed. You see, nothing is added, nothing is removed, nothing is substituted, only the atoms undergo shifting in the same molecule. That's known as rearrangement. That's all for this reactions. Hope you are clear with this. Any doubts so far, please, you can ask if you have. No doubt. So let us go to the practice questions. So before we start, let us So before we start practicing, please download a Spark Academy app from the Google Play, or the link is also provided in the description box. You can download the app to get the 10% discount. To get the 10% discount, please use the coupon code that is HAJ10. That is your Hajera Maa'm's code. In the app, we provide many things like handwritten notes, study materials, PYQs, and mock tests. Also, we run short-term courses, crash courses, long-term courses, and mock test series also for all the entrance exams like JEE Mains, NEET, Eamcet, IIT Foundation. We have the courses at both the branches of that is Narayangarh and Mehedipatnam. You can join whatever which is feasible for you. In the app you will find the videos uploaded by us for for all subjects. You can even get the live classes running, assignment session for the student, and test series section for the students, and after test also you will get the feedback analysis, and by us. So yes. So the thing is, we provide you the basic concepts. I think I have. You can see the example which we are doing daily. In our classes, we are starting right from the scratch, right? And we also provide short-term courses, all model papers, exercise questions, PYQs, and chapter-wise tests, weekend tests, grand tests, and test analysis after test attempted. You can join any of the courses like online or offline course, but if you join offline course, you get the all benefits. Whereas if you join online courses, two things are not accessible to you. That is the classroom coaching and as well as the books. So moving on to the questions, which are PYQs. Sorry, not PYQs. Practice question. So the first practice question is, halogenation of alkane follows dash mechanism. So they are asking us to know the mechanism of halogenation of alkane. Do you know the mechanism? Let Bhavan answer. Or others who are online present, please answer. What is the halogenation of alkane follow mechanism? Fast, I'm waiting. Whether it is free radical, whether it is electrophilic substitution, whether it is NSR or none. Fast. Oh, very good. Bhavana's answer. That is FRSR, free radical substitution reaction. Because I think I already told you that benzene ring containing compound ESR shows ESR, alcohol and alkyl halide shows NSR, and halogenation of alkane shows free radical substitution reaction. Very good, Bhavana. Bhavana, you want alpha hydrogen explain? Okay, I'll just tell. I'll tell the meaning of alpha. Just let me complete the practice, then I'll go to your. I'll come back to it out. Next question is, halogenation of alkene follows which mechanism? NAR, EAR, FRAR, and none. Alkene. I think I already told you, alkene always undergo addition reaction. Which addition? NAR. NAR is example of? Oh, you tell. Let the. So what is the answer for that? I'm waiting fast. Halogenation of alkene shows which one? EAR. Yes, EAR. NAR is for carbonyl compounds. Electrophilic addition always for alkenes in presence of acidic medium. For peroxide only one time, that is for HBr. That means whenever you are adding HBr to alkene in the presence of peroxide, the mechanism will be FRAR. Now the question is, phenol shows which reaction? Phenol shows which reaction? ER, ESR, NSR, FRSR. Please, my dear students, answer. Carbonyl compound is example of NAR, right? But let me know the phenol one first. Fast. Others who are online, please answer. What is phenol mechanism? 3A. Electrophilic addition reaction. Bhavana, it's addition. Phenol undergoes addition. Phenol undergoes electrophilic addition. Are you sure, Bhavana? My dear Bhavana, what is a phenol, you know? Phenol is nothing but benzene ring attached to OH. Just now I told you, wherever you find benzene ring, they undergo ESR reaction. The answer is B for that. Please don't forget about the ESR. ESR are 4 types: halogenation, hydration, sulfonation, Frederick reaction. Right? Do you remember? Yeah. Substitution. So you said ESR. Okay, okay, right. Very good, Bhavana. I think you have attempted 3 questions. Very good. So you want the alpha one, alpha. I'll tell you the meaning of this. So, you want the meaning of alpha? You want the alpha elimination? See, look here. Consider this is like CH3, CH2, CHO. Now here in this 3 carbon list, this is a functional group. The carbon next to the functional group is known as alpha carbon. The after that will be beta. If you have again gamma, the goes on, right? So this is called as alpha carbon. How many alpha hydrogens are there? 2. How many beta hydrogens are there? 3. If there is one more chain, you can call as gamma, the goes on. So hope you know the meaning of alpha and beta. It's very important. I think I told you alpha and beta. Then hydrogen. See alpha carbon, nama. This is alpha carbon. So this is how many hydrogens are there attached to this alpha? 2. 2. And for beta, how many are there? 3. Is it the question? Is it the question? To calculate number of alpha hydrogens and number of beta hydrogens? Is it the question or any other thing? Please be specific. Fast. Okay, very good. Chalo. So you can download our telegram group also. We are also providing the link. In the description box. So please download the telegram group and you can find the notifications of our classes and important updates of this, and you can also find the material PDFs available for the subjects. So I think this was a question which I gave for the homework. So now for the assignment, you have the question is, wait, assignment or homework is, yeah. So this is the homework. This is a homework. The question is this type of the type of reaction of tertiary alkyl halide is SN1, SN2, ER or ESR. Okay. Next test. So the second question for the homework is, Bhavna, you can answer here also if you are watching this. Others also can answer here because they are not You're not uploading the assignment or answers. I mean homework answers. So the next question is, there are two questions for assignment. Oh, Bhavana has answered. So the first answer she's telling is SN1. Tertiary, very good, yes. Let me give the answers for the second also. Think and tell the second one. Alkene, adding HBr in the presence of peroxide. They are giving the product also. They are asking the mechanism of this reaction. To be very good for radical addition reaction. Very good. So with this, we finish today's class. Thanks, and please don't forget to subscribe our channel and press the bell icon for notification. This is our experienced faculties. Thank you.